Okay, we're on. All right, let's look at problem J here. This problem has a whole lot of negations. It has an and it has an or. Some old person, I don't even know their name, and there's a theorem out there, but I don't know the name of the theorem. But I know that this theorem works. Okay, you ready? I'm going to call it the opposite theorem for a minute, okay? I'm going to do the opposite of everything up there. So what's the opposite of the opposite of A? Hey. What's the opposite of and? Opposite of B, opposite of or, and C. Now, if I were to shade that problem, that would be the opposite of the answer to our problem. Is it a lot easier to work with this? I think so, right? I would think it'd be a lot easier to work with A or B and C, right? As opposed to not A and not B or not C. So let's sketch what I just created here. Uh-oh, that's a problem. Just leave it right like that. Let's sketch that, but where do we need to start? Do we start with A? No, we start inside the parentheses. So let's start inside the parentheses, B and C. B and C, well, the only shaded region I will have for B and C will be that. Or A. Okay, or A would just take all of that and include all of this. So our opposite theorem, again, totally informal. JV, like very JV, right? The opposite theorem. Just made it up, basically. Okay? This is the opposite of our answer. So everything that's in white now, that's our answer. Does that make sense? It's the opposite theorem. If I graph the opposite, sometimes it doesn't help, right? Well, it would help here. What would be the opposite of this? A and B. Oh, nice. Well, A and B is really nice to graph. Sweet. I got A and B, so the opposite of that is everything in white. So the green space is not the answer. The white space is the answer. Does the opposite theorem make a little bit of sense now? Okay, so let's move on to 55C, or A and B first, and then we'll get to C. Check it out for a minute. A or B is going to be the opposite of not A and not B, right? So let's talk about A or B first. Here's A, here's B. We're told that the probability of A and B is 0.2. I'm just going to put my decimals where they belong. The probability of A is 0.45. Well, 0.2 of that 0.45 is right here, so I should have 0.25 there. Probability of B is 0.7, so that gives me what here? 0.5. And now I can do some shading. I'm going to pause. Okay, quick pause for a story and to tell some children to get out of the hallway. Probability of A or B. Well, A or B is going to be anything inside of either of these two circles. So our probability is 0.95. We've already determined that A or B is the opposite in every way, the negation of not A and not B. Therefore, we can take 1, which is the entire, well, I don't even know what you'd call that, 100%, and we're going to take away 0.95, which will give us a probability of 0.05. Now, your question, young lady, remind me name. Sierra. Let's talk about that for a moment. What would be the probability of A and B? Well, where is A and B? 0.2. So the probability of A and B is equal to 0.2. The probability of the opposite of A and B would have to then be 0.8. Right? It's the opposite of that. And opposite in this way, it doesn't necessarily mean anything mathematical other than take one minus that probability, you get the other. Okay, or you could shade and go along that way too, and that would work. Mic drop.